Continuing here in Chapter 8, Section 2, problem number 13. Don't know, can you see? No, you can't see because I've got it sitting here. And we're just doing a screen capture. But I've got the systematic hypothesis testing procedure, critical value approach, 5 steps here in front of me. I printed that out to make sure I had that handy. Because when we're doing this, this is a great thing to have. Some of us have it memorized. I have it here in front of me so I can look at it to remind myself. You might want to do that too as you go through these problems. So number 13, an automobile manufacturer recommends oil change intervals of 3,000 miles. Okay, there's a number we're going to be needing. Compare actual intervals to the recommendation. The company randomly samples, we've got 50 oil changes, set at service facilities and attains a sample mean of, so we've got a sample mean here of 3752 with standard deviation of 638 miles. Okay, coming back to all these obviously since I'm circling them. Determine whether the data provides sufficient evidence at the 5% level of significance that the population mean interval between oil changes exceeds 3,000 miles. Okay, so let's look at what we've got here. We've got 3,000 miles. And this is going to be the mean, we're going to say, of our underlying population. We're saying that the mean is, that's our average oil change and what we typically would have, our null hypothesis. So that's where we're going to go. And we'll talk more about that here in a minute and just getting these together. Random samples, 50 oil changes. So we've got an N. Our sample size of 50, it's large, greater than 30, so we'll be able to use our large sample size data. So we have a sample mean, so we've got a sample mean of 3752 miles and a standard deviation of 638 miles. So that's the standard deviation of the sample. So we're looking for evidence that our alpha equals 5% or 0.05 level of significance, that the interval between oil changes exceeds 3,000 miles. So exceeds. So let's go through our steps. Step 1, identify the null and alternative hypotheses. So I started with that, right? So our null hypothesis is that our mean is 3,000 miles. And our alternative hypothesis, let's see, it exceeds 3,000, is that so our mu alternative is greater than 3,000 miles. And again, we said that's at the alpha equals 5%. So there's step 1. So step 2 states, identify the relevant test statistic. Okay, so from this standpoint, test statistic, we're looking at a mean, and we have a large sample size. We do not know the underlying population standard deviation, so we're going to have to use the sample standard deviation. So our test statistic is going to be z equals our x bar minus mu naught. It looks like mo. Over our sample standard deviation divided by the square root of our sample size. Let's go ahead and calculate that, right? So we've got our x bar, which is, we had that 3752, minus our null hypothesis mean, which is 3,000, divided by our sample deviation, which was 638. That's going to be divided by the square root of our sample size, which was 50. And when we calculate that all out, we get 8.335. Okay, let's see. That was, oh, well, you know what I just did? Step 3 is compute the data of the value from the test statistic. I typically do that. I just realized as I'm working this, I identified the test statistic, then I went right on and did the calculation. So this is actually 2. I did this like number 1, number 2. This is number 3 right here. So I could actually just go ahead and erase this 3 because we just did that. Okay, number 2, 3. Now let's go to number 4. Number 4 then is construct the rejection region. Okay, so we have our underlying distribution, which has its mean, and we're looking at a tail out here of our alpha, and this is going to be our 0.05. So our C prime is what we used that before, finding this value of C prime. So let's see, that's going to be, we can do this back in converting back to our value here from our standard normal distribution. And let's go ahead and do that. So our Z at our alpha is going to be our Z at 0.05. So for our standard normal version there, we get that from the table, 1.645. So that's on the positive side. So I have the C prime here listed as if this was in the back at the distribution here, but since we've done it back to the standard normal, we'll be directly on this one. So our Z value here is, so with the mean here being at 1 and at 1.645 for a critical region, anything from 1.645 above, the value falls in the critical region, and we would reject a null hypothesis. So number 5 is, since 8.335 is greater than 1.645, we reject our null hypothesis. So in other words, we're saying that the data does not provide, or the data does provide significant evidence that the 5% level of significance to conclude that the average interval between oil changes exceeds the 3,000 miles.